Alright, this is lesson 34, Pascal's triangle. Okay? So Pascal was a mathematician back in the day in the 1600s, and he discovered this pattern called Pascal's triangle, but it's a pattern he discovered. And there's mathematical patterns around us. Around the world we have just patterns that are just part of the universe. They're just kind of part of the design of the universe. It's just there, okay? So you can't really change it. It's just there, okay? This is a pattern, and one of the ways we use this pattern is we apply it to coefficients when we multiply, okay? And it's used as a shortcut, okay? So, if you want Pascal's triangle, if you're on the video, you kind of want to look at the page 359. In your textbook, there's Pascal's triangle, or if you're in class, it's up here, okay? So, and basically, in Pascal's triangle, we found a use for it, or he found a use for it when we multiply. So let's say I had a problem that was really hard like this, like a plus b to the fourth power, okay? Normally, as a math student, you would have to write a plus b times a plus b times a plus b times a plus b, right? 4 times, right? We're multiplying it with itself. And then you have to multiply, you take a couple of these at a time, you're going to FOIL them, right? So you got a squared plus ab plus ab plus b squared. And then all of that times again, we could do that again here, FOIL these, right? And it gets kind of messy after a while, right? Right? And this might just take a little bit longer than to go another way. And then once you get to this point, you're still going to have to FOIL or, multiply each of these terms with each of the following terms. And it kind of all gets a little bit crazy, right? Right? Gets all these rainbows. I don't even know. It's kind of crazy, right? Kind of gets messy, right? So, Pascal found a way to do this. He's all like, well, you know what? There's always a pattern when we multiply out binomials. This only works with binomials, which is terms that have 2. And he used this thing called Pascal's triangle. Okay, so Pascal's triangle is also used for other things too, to find patterns in which ways you could go. But for now, we're going to focus on just multiplying binomials. Okay, these are the steps. You have these written down in class. Pause the video. Here we go. I'm going to do numbers 1 and 2. Okay. I'm going to show you how to multiply out binomials using Pascal's, okay? And this is the shortcut, okay? So, but you have to know how to do the shortcut in order for it to be successful, okay? So all eyes up here, pencils down. You need to watch, okay? Because you've never seen this before, okay? And it's kind of unique. So, okay. So the first thing you ever do, if you have a binomial problem that says multiply, then you know to think about Pascal's, okay? So there's 3 things you need to identify first. First thing you need to identify is the following. Is the first term. The first term is y. Second term is 4. And it's positive 4. The third thing you need to figure out is the exponent. The exponent here is 4, okay? The exponent is super important because it tells us what row on Pascal's triangle to be at, okay? So if we look up here at the board, Pascal's triangle, anything to the 4th power, we're going to use this row right here, okay? This is the 4th row. First row up here is 0, anything to the 0 power. 1st power, 2nd power, 3rd power, 4th power. So we're going to take all the numbers in the 4th power. These are our coefficients, okay? So I'm going to copy these down underneath the problem, and I'm going to spread them out a little bit. I'm not going to just write them next to each other. So I'm going to put 1. We're copying this row here. 1. Make a little space, 4, make a little space, 6, make a little space, 4, make a little space again, 1. Okay? That's the first thing we're going to do. Second thing we're going to do is take the first term and put it next to it, in its own parentheses. So we're going to put a y next to the 1 here, y, a y next to the 1 here, or the 4, I'm sorry, y next to the 6, y next to the 4, and a y next to the 4. Okay, watch carefully. All eyes up here. Since our exponent is 4, okay, since the exponent is 4, right, we're going to put a 4 here, okay, above this y. So it's going to be y to the 4th, then it's going to be y to the 3rd. This should be y squared, y to the 1st, and y to the 0 power. Okay, it's descending, okay? Then we're going to take the second term. The second term is 4, okay? We're going to put that next to each of these terms. So we got 4 here, 4, 4, 4, and 4. And we're putting it in parentheses because we have to multiply it. And we want to make sure we apply the right exponent to it. Now this one's different. We're not going to put a 4 here. We're going to put a 4 at the end. We're going backwards this time. So starting with a 4 up at the top right here, 4, and we're going backwards. Then it's going to be 3, then 2. So we're going 4, 3, 2, 1, and then 0, okay? We've just set up the problem, okay? So each of these will become terms, okay? So we're going to simplify each of these, okay? So this first one right here, 4 to the 0 is 1. 1 times 1 is 1. 1 times y to the 4th is y to the 4th. Okay, that's the first term. Second term, 4 to the 1st is 4. 4 times 4 is 16. 16 times y to the 3rd is positive 16 y to the 3rd. Okay, next one, 4 squared. 4 squared is 16. 16 times 6 is positive 96. 96 times y squared is positive 96 y squared. Continuing, next term, 4 to the 3rd is 4 times 4, which is 16, times 4 again is 64, times 4 out here is going to be 256. 256 times y to the 1st is positive 256 y to the 1st, or 256y. Last one, 4 to the 4th. 4 times 4 again is 16, times 4 is 64, times 4 again is 256. Y to the 0 is 1. 1 times 1 is 1, times 256 is positive 256. Okay? That's it. We're done.
How is 4th, 3rd? Oh,
4th?
4 right there. Right?
Yeah. Okay? I'm gonna do this one more time, okay? I'm gonna explain it one more time. Believe it or not, this is easier than you multiplying it out, okay? Because if you were to multiply it out, it'd take you a long time to get to it. Because the first time I showed you this, I did a lot of explaining, but once you understand the process, it goes pretty quickly, okay? So again, watch me from the top. Number 1. First thing you do is identify the first term and second term. First term is y. Second term is 4. Then we find the exponent. Our exponent is 4. It reveals what level of Pascal's I have to go to. It's going to be something to the 4th, so I'm going to use 1, 4, 6, 4, 1. I'm writing these out and spreading them out. Then I take the first term and I write them next to each of these exponent, or next to each of these coefficients. Then I look at my exponent. It's 4. I'm starting over here. I'm writing 4, 3, 2, 1, 0. Then I take the second number, put it next to it in its own parentheses. So it's 4 is my second number or term. Then I go backwards, starting with 4 to the 4th, 3, 2, 1, 0. Then I simplify. This all turns into y to the 4th. This all turns to positive 16y cubed. This all turns into positive 96y squared. This all turns into positive 256y, and the last one's positive 256. Okay? So what we're doing here is we're working in chunks, okay? Instead of you multiplying it all out, you're going to work in chunks, okay? So that's something to the 4th power. Raise your hand if you think that it's faster just to multiply. Raise your hand if you say it's easier to do this. Okay, good. So this is easier, because look at the next one. 6th power, right? Could you imagine multiplying this 6 times? That'd be ridiculous, right? So, number 2. Okay, first term. Watch up here, eyes up here, pencils down. You'll have plenty of time to write, I promise, okay? First term is u. Second term is 2. Third term is, or not the third term, exponent is 6, okay? That reveals that I have to go to the 6th row of the Pascal's triangle. Okay, looking up here, 6th row, we have u, or to the 0 power is 1, first, second, third, fourth, fifth, 6 powers right here. Or I should say 6. Okay, so I'm using these coefficients here, which is 1, 6, 15, 20, 15, 6, and 1, okay? And you might say, oh, that's really scary. It's not that scary. So first thing you do is you write 1, Then the next term, I'm going to spread it out. 1, 6, 15, 20, 15, 6, and 1. Okay? Then I take the first term, which is u. Okay? Putting u in its own parentheses in each of these. Okay, and since it's u to the 6th power, we're just going to write descending order. It's going to be u to the 6th, u to the 5th, 4, 3, 2, 1, 0. Then we take the second term, which is 2. So we got 2 in its own parentheses. And 2 here. And then over here we have 2 to the 6th, 5, 4, 3, 2, 1, and 0. First term here, we're focusing on the first term here. 2 to the 0 is 1. 1 times 1 is 1. 1 times u to the 6th is just u to the 6th. That's the easiest term, always. Next one, 2 to the 1st is 2 times 6 is 12. 12 times u to the 5th is positive 12 u to the 5th. Next one, 2 squared. 2 squared is 4. 4 times 15. 60 times u to the 4th is going to be 60 u to the 4th. Then we got 2 cubed. 2 times 2 is 4 times 2 is 8. 8 times 20 is 160. 160 times u cubed is positive 160 u cubed. Continuing, 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 15 is positive 240 u squared. Continuing, 2 to the 5th, 2 to the 5th is 2 times 2 times, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again is 32. 32 times 6 is 192. 192 times u to the 1st is positive 192 u. I think that's right. I'll just double check it. 32 times 6 is 12. Yep, 192. Okay, just checking my work. And the last one, 2 to the 6th power is 2 times 2, which is 4 times 2 is 8, times 2 again is 16, times 2 is 32, times 2 is 64, times u to the 0 is 1, times 1 again is just positive 64. Okay, that's it. That's your answer. This long answer, okay? I should use a nicer box. Okay? Alright, so again, this takes a little while to learn at first, but this is all patterns and working in chunks, okay? That's the idea. You're working in chunks. Instead of you doing this whole problem, working in little bites, and then you put them all together and you get your final answer. Did you all get that? Okay, so what I'd like you to do before you start writing is turn your neighbor. 1 cell 2 is about number 1, 2 cell 1 is about number v plus 3 cubed, okay? We'll start off with an easy one. Now you can multiply this out, v plus 3 times v plus 3 times v plus 3, or we can use Pascal's, okay? Let's just use Pascal's. This is an easier one. What's our first term, everyone?
V.
V, okay, so first term is v. Second term is what?
3.
Oh, 3. And then the exponent? 3. Okay, so we're going to go to the third level of Pascal's. What are my coefficients on the third level? Okay, good. 1, 3, 3, 1. So we're going to write down 1, leave a little space, 3, 3, and 1. Okay? Then we need to figure out then we need to write down our first term, okay, which is v. And we're putting it in its own parentheses, and we'll see exactly why in the next example. But this is something you need to do. Stay in the habit of doing it. Okay. What should I do next? I wrote the v's down. Exponents. Yep. And 3. Yep. Starting with 3, 2, 1, 0. Next one. Next term is 3. So we write 3 in its own parentheses. Okay, now what should I do? Good, we do it backwards, okay? So we got 3, 2, 1, 0. Now I got a question. What happens if you don't get to 0 in one part of the answer? Then you did something wrong, right? You probably copied something down wrong. Okay, did y'all get that? Sometimes when I've done this kind of work before, I may have gone to 0 before I was supposed to, or I never got to 0. It means I copied the wrong line down. Okay? Yeah, question?
You say going backwards, what do you mean?
Going backwards, I started here at 3. Oh, right here, 3. Then 2, 1. You see I'm going backwards? Yeah? Okay, good. Okay, then we simplify each of these, okay? So 3 to the 0 is 1 times 1 is, okay, 1 times v cubed is, good. That one's always the easiest, by the way. Next one, 3 to the first is, times 3 is, 9 times v squared is, positive or negative? Good, so I want you to say that in your head, positive 9v squared, okay, because you have to write positive or the plus sign. Okay, next one, 3 squared is, nope, 9. 9 times 3 is, 27 times v to the first is, positive 27v. Last one, 3 cubed is,
27.
positive or negative?
Positive.
Good, and the v to the 0 is 1 times 1, still 27, right? That's it, that's your answer. Is that easier or harder?
Easier.
Yeah, it is easier, right? Alright, next one. So number 4 is a little harder. A little bit of a curveball, but not that much harder if you just followed my steps, okay? So first term is u. So we're going to write u as our first term. Second term, -4. Good, I'm glad you caught that. -4. What is our exponent? 3, okay? So we're going to use the same Pascal's triangle level of 1, 3, 3, 1. So we're spreading those out. We've got 1, 3, 3, 1. Okay. First term is u. And at this point, you could go pretty quick. You could go u to the third, u squared, u to the first, and u to the 0. Then the second one, and I'm glad someone noticed there's a negative sign, right? -4. So we're going to go backwards, right? Or we're putting -4 to the 0 power, -4 to the first, -4 to the second, -4 to the third. Okay? Yeah.
It's going to be different if the exponents are negative.
There won't be negative exponents in your homework tonight. Or ever, no. Yeah. Actually, tomorrow there'll be tomorrow there'll be exponents on the inside, but okay, here we go. So now we simplify each of these. So we got -4 to the 0 power is 1 times 1 is, so it's going to be u to the third. Good. Second term, -4 to the first power is, -4 times 3 is, what's -12 times u squared? Good, -12u squared. That's the difference on this problem. You see that? There's a negative sign there. You have to be careful. Next one, -4 squared is? 16 times 3 is? 48 times u to the first is? Positive 48u. Y'all get that? Next one, -4 to the third? Negative what? -64 times u to the 0? And times 1 is still -64. Right? Did y'all get that?
Yeah.
So on this last example, you have to be sure you're careful with your negatives. You see how there's negative terms? You need those, otherwise you're going to get the wrong answer. Even though you set it up right, you could still get the wrong answer, okay? And of course, this is a lot easier, right, than than multiplying. Imagine multiplying negatives and positives through the whole thing and then combining like terms. It's just a big mess, right? So this is a faster way to do this. Yes?
Do we have to memorize that triangle?
No, that's a good question. You don't have to memorize it, but you have to know how to create it. Which isn't that hard. So, it's pretty basic. You should practice it, though, because I will not provide it on a test. Yes?
What's the first one? Positive.
Negative 4 to the 0 power. Anything to the 0 power is 1. Yeah. It could be like negative infinity to the 0 power, still 1.
Never negative 1 0.
Yeah. Unless there's a negative sign on the outside of the parentheses. Okay? Y'all following me? Okay. That concludes this lesson.